Hi, my name is Michelle Mikes, the Math Supervisor for the Cobb County School District. Geometry is one of the best domains in math to model conceptual understanding and to encourage investigation and discovery in your classroom. In 8th grade, students have to know and apply the volume of cylinders, cones, and spheres. What better way than to incorporate two-color counters and relational geosolids to solidify the conceptual understanding as an effective instructional practice to promote retention of that math concept. In this target video, you will see the how-to on the use of the manipulatives with your students and the action in a classroom. First, let's take a look at the demonstration of the manipulatives. In Unit 3, you teach volume of circular figures, and in previous grades, students have learned about the volume of prisms. A great manipulative to use to compare the volumes of circular solids is the relational geosolids. And these are a great manipulative because they're proportional, so the bases are equal and the heights are equal to each other. So for example, tie in your volume of circular solids, you would remind the students about how they found the volume of rectangular prisms. And by doing that, they found the area of the bases and then they multiplied it by the height. So by doing a little mini lesson, a reminder of this, you can go right into finding the volume of cylinders. So in 5th through 7th grade, students have investigated the volume of prisms. By 8th grade, they're learning the volume of a cylinder, and they want to make that relationship back to the volume of the rectangular prisms is that you would actually find the area of the base, which on this would be circular, and you'd multiply it by the height. So to bring that relationship forward, you can also use two-color counters. And with the two-color counters, you can stack up 4 of these two-color counters and set them next to these 8 two-color counters and ask the students what the relationship is between these two sets of two-color counters that are in the shape of a cylinder. With that, you want to ask them what would be the difference between the volumes between these two-color counters that are set up as cylinders. And the understanding is that these are stacked circles, and that the relationship between this geosolid and these two-color counters is that they both form a cylinder, but these are actually showing them how they are stacked circles. So the students would have the understanding that the area of a circle multiplied by the height would find the volume of a cylinder, which is just pi r squared times the height. So once the students have found the volume of cylinders, we want to do that comparison of how they use the area of the base multiplied by the height to find the volume of a cone. And with these geosolids, like I said before, they have the same area of the base and the same height. So you can do that comparison. A great way to do the comparison is to use some colored water. Rice is messy that we found in the past. Another item you can use is moon sand, but today we'll model it using water. All right, so once students have found the volume of a cylinder, we want to have them figure out by investigation the volume of a cone. So by using the relational geosolids, you can see that the height is the same between the cone and the cylinder and that the bases are the same area. So with that, we can do a comparison using water. If you try rice, many times it will come out to be too messy. We found water to work best with students. So ask your students to fill up the cone with water and do not fill it past that baseline that holds the lid to it. Otherwise you'll fill up the cone too much. So that's about as full as they need to fill it. Have them fill it into the cylinder and figure out what proportion of the cylinder does the cone fill. So students will come up to say, hopefully, that is 1/3 of the cylinder, and to find out that the relationship is that 3 of these cones will actually fill up 1 cylinder. We relate it actually back to the formula. We look at the pi r squared, which is the area of the base, times the height. For a cone, it's only going to fill 1/3, and that's why the formula is 1/3 pi r squared times the height. The next relationship you want to share with the students is a relationship between the sphere and the cylinder. And the sphere is set up so that the height of the sphere is the same as the height of the cylinder, and then also the diameter of the sphere is the same as the diameter of the cylinder. So have them fill up the cylinder with water. And again, you don't want to fill to the very top rim. And have them pour it into the cylinder. And then you want them to figure out what the relationship is, how much of the sphere will actually fill up that cylinder. So the relationship of the formula of the volume of a cylinder in comparison to a sphere is that we know that the sphere will fill up 2/3 of the cylinder. So now we have 2/3 pi r squared times the height. But the problem is that we don't really have a height here in this sphere. So the height of the sphere is actually the diameter, and the diameter is made up of 2 radii. So if we change the formula and we say 2/3 pi r squared times 2r, then we can combine like terms by using the associative property and change the formula around to 2/3 times 2, which is 4/3, r squared times r, which is r cubed, and now we have the formula of a sphere of 4/3 pi r cubed. We have found hands-on student investigation to be the most effective way to increase student learning. Let's take a look at students working with these manipulatives in the classroom. At Awtrey Middle School, Mrs. Clody began her lesson with an opening of introducing a real-world application problem of the local town needing to replace their spherical water storage tank with a cylindrical shaped tank. During the opening, the students investigated volume using the 2-color counters and 3D solids to discover the relationship of the volume formulas to develop a concrete understanding. During the work session, the students practiced finding the volume of 3D figures, given their dimensions, to practice representational understanding. And to close the lesson, and to tie to the abstract, Mrs. Clody had the students revisit the application problem from the opening to decide upon the dimensions of a new water tank that has equal capacity and a minimum height. The students were to explain the dimensions they chose and justify why. Here is some feedback from students that took part in this lesson.
A teacher can lecture to you all day long, but you really have to see something to kind of understand it. Even if you're not like a visual kind of learner, you kind of have to see it and kind of relate to it, to your kind of real world problems.
Using the solids helped us relate it more to real life experiences.
Any teacher can give you a formula and tell you how to solve something, but once you have a visual, you can take the visual and break it into pieces and kind of solve for the smaller pieces and then put it all together to make the bigger picture.
As you can see, using 2-color counters and relational geosolids promotes the retention and the understanding of the volume of cylinders, cones, and spheres. Find these manipulatives in your building and put your students to work through investigation and discovery to increase and sustain your students' knowledge. Here are a couple of effective web resources that simulate volume to reinforce your instruction for students to review and use for remediation. Thank you for your time. As effective teachers, let's continue to inspire and engage our students in mathematics.